Which number is bigger, 0.9 or 0.87? Most students think that 0.87 is bigger because 87 is bigger than 9. But that's not correct. Let's see why and understand how to compare decimals in today's video. When we learned decimals, we learned that if I have a number 8.762, then the number or the digits that are on the left hand side of the decimal represent the whole number, and the digits that are on the right hand side of the number represent the decimal part. And the place values of the decimal part is tenth, also represented numerically as 1 over 10. 6 is represented as hundredth, numerically as 1 over 100, and 2 as 1 over 1000, and can also be written as thousandth, and so on. So when I have to compare two decimal numbers, the first thing I compare is the whole number. Now the number or the example I have taken here, the whole number is 0 at both the places. The next thing we compare is the decimal part. And when I am comparing decimal numbers, I move from the decimal towards the right hand side. So the first thing I check is the 10th value. Now here the 10th digit here is 9 and the 10th digit here is 8. Since 9 is greater than 8, that is why zero point 0.9 is bigger than 0.87. Let's start with example number 1, wherein I have a number 13.19 and 5.46, wherein the whole numbers itself are different. So I will compare the whole numbers. Now 13 is bigger than 5. So 13.19 is bigger than 5.46. Example number 2. When the whole numbers are same, then in case of decimals, we start comparing the digits from the left hand side towards the right hand side. That means I will first compare the 10th digit in both the decimals. Here 6 is greater than 2. That is why 7.6 would be greater than 7.2. Number 3. Now again the whole numbers are same here. I start moving from the decimal towards the right hand side. Now 3 is same at both the places, and then I go to the 100th place, which is 6. Now 6 is greater than 4. So again in this case, since 6 is greater, 1.36 is greater than 1.34. So if the whole numbers are same, I will start moving from the decimal towards the right hand side and compare the digits one by one. Let's understand comparison of decimals with few more examples. Now the whole number is same in both of them. So I start moving from my decimal digits towards the right. The first digit at the 1/10th place is 1 here, and the 1/10th digit in the second number is 3 here. Now since 3 is greater than 1, that is why 5.3 would be bigger than 5.17. Now it seems as if 17 is bigger than 3 and that 5.17 should be bigger, but 5.3 is bigger. And to make the calculations easy, it is a trick that you can make the number of digits same for both the numbers so that you don't have confusion. For example, here I have 2 digits after the decimal. So I can put 10 here and make the number of digits same. Now putting a 0 in the end doesn't change the place value of 3, and that's the reason, since nothing is changing, these trailing zeros can be added. And now you can see that 30 is greater than 17. That is why 5.3 is bigger than 5.17. Or another logical way to understand is the whole number in both of them is 5, and in the second number I have 30 parts out of total 100 parts, and in 17 I have 17 parts out of total 100 parts, and that is why 5.3 is bigger than 5.17. Let's come to example number 2. Now in example number 2, 0.02 and 0.20. As explained, that if I add a 0 in the end, that is known as a trailing zero. Any zero which is not changing the place value of any number doesn't hold any value. So that is why even if I erase the 0, the value of the number doesn't change, and that is why 0.02 is equal to 0.02. So the answer here is equal. Next example, 1.237 and 1.25. The whole number is same in both of them. We start with a decimal digit and move towards the right. The first digit or the 1/10 digit is same in both of them. And then we move to the 100th digit, and the 100th digit is bigger in the second number. So that is why 1.25 would be bigger than 1.237. And for a better understanding, you can always add a trailing zero. And now you can compare that 250 is bigger than 237, and that is why 1.25 is bigger than 1.237. Next example, here I have a 2.09 and 2.9. Now the whole number is same again here. From the decimal, I start moving towards the right. The 1/10 digit is 0 here, and the 10th digit here is 9. And since 9 is greater than 0, that is why 2.9 would be greater than 2.09. And to remove a confusion, any confusion here, I can always put a trailing 0 here. So 90 is greater than 9. That's the reason 2.9 is bigger. Remember, the common mistakes in comparing decimal is thinking that a longer or a bigger decimal part would mean a bigger decimal, but that doesn't hold true. And not understanding the value of trailing zero. So whenever you have to compare two decimal numbers, to avoid any confusion, the best way is to make the number of digits after the decimal same by putting trailing zeros. Let's understand comparison and putting trailing zeros with two more examples. I have a number here 2.16 and 2.8. Here I have two digits after the decimal, and in this I have just one digit after the decimal. To avoid any confusion, put a trailing zero here. When I put the trailing zeros, you can compare that 80 is bigger than 16. I've made the number of digits equal. Now this is 80 parts out of total 100 parts, and this is 16 parts out of total 100 parts. So I can clearly see that 18 is bigger than 16, and that is why 2.8 is bigger than 2.16. And next example is 0.54 and 0.096. Which one is bigger? Again, always make the number of digits after the decimal same so that there is no confusion. Here I have 1, 2, 3 digits after the decimal, and here I have 2 digits after the decimal. I will put a 0 here to make the number of digits 3 on both the sides. Now I can clearly see that 540 is bigger than 96, and that is why 0.54 is bigger than 0.096. This was all about understanding comparing decimals in today's video. And I have a challenge question for you. Which one is bigger, 6.205 or 6.25? I want your answers in the comment section below. If you like the video, do like, subscribe. Wish you the best.